Learning Outcome 2.5 and 2.6, Finding the Impulse Response from Input-Output Equations. The problem we're going to look at is if we're given a system with an input x of n and an output y of n, we call the system h of n. You saw this introduced earlier in this chapter. H of n is called the impulse response. For many problems, we know the mathematical relationship between x of n and y of n, like we did in Chapter 1. And in order to apply techniques from Chapter 2 and beyond, we need to know what is h of n. The same problem exists in continuous time, where our input is now x of t and our output is y of t, and we want to find the impulse response, which is now h of t for continuous time. Remember the definition of an impulse response. It is the response of a system where the input is a unit impulse, either delta of n if we're in discrete time or delta of t if we're in continuous time. Notice this word, response. It's the same thing as this word response. Response just means output, answer, how the system responds to a particular input. Therefore, for our systems, if we're in the discrete time, we're going to set our input x of n to delta of n, and we're going to define that therefore the response is going to be h of n. And if we're in continuous time, the input x of t will be delta of t, and our output y of t will therefore be h of t. You need to know that impulse response is the name associated with h of n and h of t. They'll be used interchangeably. And you need to know that h of n is just the output of our system, our y, if our input is delta of n or delta of t. We'll apply this first in Learning Outcome 2.5 to the discrete time case, and then in Learning Outcome 2.6 to the continuous time case.